finish up chapter 9. Okay, there are two things that I want to do. We've already set up the data. I want to run the regression tree. Okay, but before that, there is one last thing I want to go back to. Okay, so I'm going to first of all go ahead and run all. Okay, so now I want to go back to the best tree that we created using the best CP value. So we look for the minimum X error. X error is the cross-validation error. So corresponding to the least X error value, we got the CP value, and then we ran the prune method with that CP to prune back. Okay, so I want to go back to that tree and then want to show you how to use the tree. Okay, you can, if you run the rpart.rules, you're going to get all the rules printed. Okay, so rules will be for each of the leaf node. What is the path that you take from the root node to each of the leaf nodes? That's what is given here. And let's take a hypothetical new observation. Okay, so if a new case comes in with these values for the predictors, okay, so sometimes we may not use some of the predictors, okay, which is fine. Okay, with these as the values for the new predictor, how do you use the decision tree to come up with a classification? Okay, so we can look at the tree, okay, which is right here. Okay, so if the new case, okay, let me see whether I can do this. Okay, so this is the, I believe this is the one. All right, okay. So let's put that on one side, and let's look at the new case. So when you start from the root node, so the root node is income. So income less than 114 goes to the left side, greater than or equal to, say, you need to pay attention to where the equal sign is. Okay, this is strict inequality going to the left side. Now greater than or equal to 114 will go to the right side. Now the new case income is 110. So 110 being less than 114, you take the left branch. Okay. The next predictor is CCAVG, and the CCAVG value for the new record is 4. So if it is less than 3, you go to the left side. Greater than or equal to 3, you go to the right side. So now you go to the right side. Okay. Now we get to income back again. Okay, so we are now further dividing income. So income less than 92 to the left side, greater than or equal to 92 on the right side. So the income being 110,000, so you go to the right side. So then you have family. Okay, so now look for family. Family is 2. So less than 3 goes this way. So that's the path you have to take. And the next is education. Education is equal to 2. Okay, less than 2, you will go to the left side, but greater than or equal to 2, you have to go to the right side. Okay, and then education greater than or equal to 3 will go to the left side. Okay, and so we go to the right side. That's a leaf node. And the leaf node is just one observation, and 5 out of 5 or 1. So your prediction will be 1. Okay, so you can use the rules here as well. Okay, so you can look at rules. So income is 110,000. So look for the rule. So there are several rules with income of 10,000. Okay, and then you have CC average should be greater than or equal to 3. So here is one that satisfies the rule. Well, no, this the income does not satisfy. Okay, so look for a rule that satisfies both. Okay, here is one. So income and CC average. Okay, so that's good. But education, it doesn't satisfy. So that one is strictly greater than or equal to 3 for education, but our education is 2. So here it is. Well, here the income doesn't match. Okay, so all right. So here is one where everything matches. Okay, income is good, CC AVG is good, education is good, family is less than 3 is good. So personal loan, our prediction for the class is personal loan equal to 1. Okay, so you use the tree, or if you're manually looking at it, then you can just look at the tree and you can figure out what the path should be, and the leaf node will give you the classification. But when you want to automate this, then you have to use these rules, and of course R automatically creates those rules and it will apply the rule. When you use predict, that this is what R does. Okay, it figures out the rule, okay, matches the actual observation with the rules, and it comes to a classification decision.